Hey guys, so this is the exam 3 review for Math 141 over chapters 9, 10, and 11. If you have me as an instructor, I'm just going to go through real quick with what notes you get for the exam, which there's pretty extensive notes for this one. If you have someone else, you should check in with them, so this just applies to my class. So I have this sheet with all the conics and sort of all the definitions, so for my class you get that. And then reminder on how to evaluate a determinant. Once you've done that a couple of times, probably you have it memorized anyhow, but there it is. Cramer's rule for 3x3 systems, or 3x4 actually. Partial fractions, just a reminder of how to set them up, and again, if you've done this section, it's very likely you know all of this, but it's on the sheet. And then, even if you've done the section, you probably don't have these ones memorized, and so this is our arithmetic sequences and sums, and likewise geometric sequences and sums. And so those are all the formulas you'll have for the test. If you want to see the notes, they're in the exam 3 folder, and so you can pull those up before the test and take a look. And actually, as you're studying for the test, I'd encourage you to print off a copy of that, and because then you're kind of studying for the test with the materials that you would be taking the test with, getting used to the materials and knowing what's there and what's not. Okay, so we are starting in chapter 10, so we're going to just kind of go the same order that we encountered the material. So I'm starting with 10.3 because, like I said before, my preference is to do parabolas before ellipses and hyperbola. And so for this one, we're given find the equation of parabola with the directrix at x equals -5 and a focus at 1, 2. Okay, so directrix at -5 would be right here. X equals, so it's a vertical line. Focus is at x is -1, y is 2. That's right there. And so we know the vertex is halfway between the focus and the directrix, because that distance is a both directions. So just looking at the graph, that puts my vertex right there. So now I know that HK for the vertex is at -3, 2. And parabola always eat their focus, so it's got to be opening to the right, and so it's doing this thing, and that's a y squared positive. And again, that's on the sheet. We also know from this that a is 2. That's going to let us finish graphing, and on the exam I would ask for the graph. So we're going to go, if a is 2, then 2a would be 4. So 4 up from the focus and 4 down from the focus. And then just try to make something that kind of looks like a parabola. And so then our equation is going to be, like I said, a y squared positive, so it's y, and careful not to do hk instead of kh, because the y is leading. So y minus 2, that's our squared term. This would be 4a, so 4 times 2 would make an 8 right there. And then x minus -3, so that's plus 3. Not squared because we're still in parabolas, so it's the ellipses and hyperbola where they're both squared. Okay, find the vertex, focus, directrix of the parabola graph. So this time we're given one that's not quite in the right form. And so I'm going to do my x squared minus 4x. I'll leave myself some space to complete the square. I'm going to bring the y over to this side, so -8y. I'm going to bring the 12 over, so I'll make it a plus 12 on that side. And then we'll complete the square in x, so half of 4 is 2, squared makes 4. And plus 4 on both sides. And then here I'm able to factor a bit. And here I'm going to collect some terms. And then I'm going to factor an 8 out. Actually, sorry, I'm going to factor a -8 out. And then careful right there, it's going to flip the sign to a -2. And so now I have my vertex. It's at 2, 2. And then the rest I'll get from the graph. This is an x squared negative, so it's opening down. And I have a vertex at 2, 2. And I know a, since since 4a equals 8, dividing both sides, a equals 2. I again ignore the sign. I do the sign to figure out the orientation, and I don't worry about it in terms of a. So then that's gonna, if that's our vertex, our focus, let me change colors here, is gonna be right there. And then it's gonna be, since a is 2, it'll be 4 to either side. Oops, that's 5. Ignore that one. So it should look kind of like that. And then our focus appears to be at 2, 0. And then our directrix, so is A, in this case, above the parabola. So it'd be right there. So directrix is y equals 4. So this is 10.1, the ellipse. I'll do the same thing in this section, one where we're given an equation and we find the stuff, and one where we have the stuff and we find the equation. Those are kind of the two problem styles we've been working with. So here I'm going to go x squared plus 8x. I'm going to leave some room right there. I'm going to factor a 4 out of these two because I need to be playing y squared inside in order to complete the square. So I'll make this a 4y. And I'll leave some more room, equals negative 16. And then I'll complete the square in x, and half of 8 is 4, and then squared would be 16. I should have a plus in there. And then I'll complete the square in y. Half of 4 is 2. 2 squared makes 4, but it's not a real 4. It's really a 4 times 4, so that's actually a 16 in disguise, because if I distribute this back, you'll see this piece I added turns into 16, so we need that. So then factoring, this piece will be x plus 4 quantity squared. This is going to be plus 4 y plus 2 quantity squared. 2 of those cancel out, and I'm left with 16. So then what I want to do is divide that 16 out, because remember this side has to be 1. And that gets me x plus 4 quantity squared over 16. 4 over 16 is 4. So y plus 2 quantity squared equals 1. So this one, stuff we know about it so far is that the center is going to be at negative 4 and negative 2. So negative 4, negative 2, that's right there. And we know A and we know B. So A is 4, B is 2. And then remember this goes A squared, so 16 minus B squared, which was 4, equals C squared. So that means that 12 equals C squared, or root 12, which would be 2 root 3, because that's a 4 times a 3, equals C. And for graphing purposes, this would be about 3.4. So to get, close that parenthesis, to get the rest of the vertices and foci, I'm going to graph. So I know A was, what was A? A was 4, so that's going to go this to this. I know it's going this way because big numbers under x. B is 2, so that's the minor axis. And that gets me something sort of ellipse-shaped, hopefully. And then the foci are going to be right kind of in there. And if I draw that, it kind of helps me get the rest of the stuff right. So for the vertex, we got one at x is 0, y is negative 2. We have one at x is, looks like negative 8, and y is negative 2. And then for the foci, the negative 2 is the one that keeps showing up, so that's the one that's going to stay. And then the x-coordinate, we're starting off at negative 4, and we're going plus or minus 2 root 3 either direction. And then that's the y is still -2. So there's all the stuff that was asked for, and then the graph. So number 4 goes, find the equation of an ellipse with a focus at -2, 3, vertex -2, 0, center at -2, 4, and graph. So I'm going to get the stuff graphed, and that's going to give us some information. We have the center was at -2 and then 4. We have a focus at -2, 3, and a vertex at -2, 0. So this is center to focus, so that is C. So that's 1. Center to vertex, so that's A. And that was 4. And with that I can find B. So remember this goes, this would be, it's a squared minus b squared equals c squared. So switching these around, I get a squared minus c squared equals b squared. So I'm just subtracting that over and adding this. So that is 16 minus 1 equals b squared, or 15 is b squared, or root 15 equals b. And so root 15 is going to be a little less than 4 for graphing purposes. And once I have this side, I can use symmetry to fill in the rest. And so this is going to be just almost a circle. It's just a hair under. It's a hair squeezed, kind of that way. 2, 4. So it should look something like that. And then our equation will be, let's see, here's our center. So x minus -2 would be plus 2. And then plus y minus 4. That's going to equal 1. And b right there was 15. A was 4, so a squared is going to be 16. And then this was 4 this way, and just a little less than 4 this way. So it's just barely a tall, skinny one. So and everything's running along the y-axis. So 16 goes under y, and the 15 goes under the x. Okay, 10.2, the hyperbola. So this is given the stuff, find the equation. So again, we'll graph it, kind of see where we end up. Center is at -4, 3, so x is -4, y is -3. We have a vertex at -4, -4, and a focus at -4, -5. So remember, the hyperbola kind of eats the focus, so this is would be the bottom half, and we'd have matching points up there. So let's see, what do we know? We know A is center to vertex, so we know A is 1. We know C is center to focus, so we know C is 2. And this one goes a squared plus b squared is c squared, so 1 squared plus b squared is 2 squared. So b squared, this would be 4 minus 1, so that's 3. So b is going to be root 3, or about 1.7 for graphing purposes. And so then our equation we can get, so our center is right there. So that's going to be, let's see, this thing is transverse y, so that means we're going to have leading in y. So it's running parallel to the y-axis, and it's going to open this way. So we got y plus 3 squared, and that's over a squared, because in this one the a and b stay put, and it's the x and y that swap, and that makes one term of the other negative. And then this will be x minus 4, or minus -4, so plus 4 squared. And then that's over b squared, which was 3 right there. And that equals 1. And we're also supposed to find the equations of the asymptotes. And remember, those are on that sheet of notes. So this is going to go, it goes y minus k, so this piece. So y plus 3 equals plus or minus. In this case, it's rise over run, so it's going to be a over b. And let's see, b this time, let me do this over here. So our slope is a over b, and that would be a is 1 and b is root 3. And so strictly speaking, we should rationalize that. So I'm going to do a little root 3 right there to clean this up. And that gets me root 3 over 3. Probably wouldn't mark off on it on the test, but this is really the proper answer. And then x plus 4. So it's just our y minus k, x minus h, and then our slope. And remember, this reverse is dependent on the orientation of the hyperbola. So let me get the rest of the graph drawn in. B is 1.7, so that's about here and about there. And that's my focus, so the box, oops, a little too far there, is going to be like that. And then we're going to have asymptotes running this way and that way. And then the graph will go through the vertice. So right here and kind of like that. Oop, that was the focus, kind of like that. So ignore that one. And these are fairly imprecise graphs, although you should draw it through the vertex, not the focus like I just tried to do. And let's see, so we got equation, asymptotes, and graphs. So I think that is it on that one. Okay, and then hyperbolas seem hard enough that I usually just give it in the right form if you get the equation version. So we're supposed to find the center, vertice, foci, asymptotes of the hyperbola and graph it. So looking at this, we know a is 4, we know b is 2, and then c we can find by saying 4 squared is 16 plus 2 squared is 4, makes c squared, so 20 is c squared, root both sides, root 20 equals c, and then this simplified would be exactly 2.5. And for graphing purposes, that's about 4.5 or so. And we're supposed to find center, so we can do that right from the equation. So the center is going to be positive 3, positive 1. And then the rest of it, I'm going to get the graph going and then use that to help fill in the rest. So let's see, what do we know? We know the center is at 3, 1, so right here. We know a is 4, and so that's going to be center to the vertex. And this is leading in x, so that means everything should be running parallel to x-axis, and it's going to open this way. So then that means a is running that way. So here and here. And the focus is about 4.5, so that would be about there and there. And then b is 2, so that's up 2 and then down 2 from the center. So then that defines sort of the box. I have some construction happening upstairs, so if something loud happens, apologies. And so just to finish off the graph, it would look kind of like that. And then from there, we'll get the rest of the stuff. So we have center already, we have the vertice. So now I can just read those off the graph. I have one here at, looks like x is -1, y is 1. I have one out here at, I think that is 7, 1. Foci, so that's going to be, it's the x that's changing, so we're going to be starting from 3. And either going 4.5 this way or that way, but we'll write that as plus or minus the 2 root 5, so we'll do the exact solution. On the test, please give the exact one, not the decimal. And then y is 1 still. And then we just need our asymptotes, so I always just look right back at the equation. So y minus 1 equals plus or minus, and this time it's going to be b over a, rise over run. So you can see it's 2 over 4 or 1/2, and then I just grabbed the x from right there. Okay, so 9.3 had a couple of things in it. It had nonlinear equations and inequalities. And for the nonlinear equations, we had ones where you could do elimination and ones where we would do substitution. And then we're graphing and shading those nonlinear inequalities also. So this one is a system of equations, and I would solve that by elimination. And that's because I have x squareds and y squareds in both terms, so I'm able to eliminate something. So I'm going to do this one by -3. I should really write it like that. And that's going to make this be -3x squared minus 3y squared equals -3 times 26 is -78. And 3x squared plus 25y squared equals 100. These cancel. 25 minus 3, that's going to leave 22y squared. And on this side it equals 22. That's always a good sign. I'll divide the 22 on both sides. And I get y squared equals 1. So that means y equals plus or minus 1. Be careful not to lose one of the solutions. And then I'm just going to put that into this easier equation. So x squared plus 1 squared equals 26. Move the 1 over. X squared equals 25. So then x equals plus or minus 5. And you can see if I do this with the -1, I'm going to get the exact same thing. It's going to come out positive when I move it over. So that gives us a total of 4 answers. And so we have x could be 5 and y is 1. X could be 5 and y is -1. X could be -5 when y is 1. And x could be -5 when y is -1. Number 8, this one they don't have the same variable. I mean, they have the same x and y, but they're not squared. So I would do a substitution on this, and y is the easiest thing to get by itself. So I'm just going to rewrite this as y equals x plus 2. I'm going to take this and substitute it in for y right there. So that's going to be x squared plus x plus 2 squared equals 10. And then squaring this, x squared plus 4x plus 4, and that's a FOIL. Careful not to fake FOIL. That equals 10. I'm going to bring the 10 over and collect some terms. So that'll be 2x squared plus 4x and minus 10 on both sides. So that would be minus 6 equals 0. And then I notice there's this common factor 2. I could either factor it out or I could just divide both sides by 2, either way. And so if I do that, now I have x squared plus 2x minus 3 equals 0. This I can factor. And that's going to be plus 3 and minus 1. And so x equals -3, x equals 1. Once I have those, I'm going to come back to the really easy equation, plug them in and get the y values. So if x equals -3, then y equals -3 plus 2, or -1. So that gives us -3, 1. And then if x equals 1, so then I have y equals 1 plus 2 makes 3. So that would be 1, 3 for our second solution. Okay, so then we hit the nonlinear inequalities, and we're actually going to see some linear inequalities mixed in, but they're going to be two-dimensional. And this is the thing where we shade the graph and then look for the overlapping section. So we're going to use some transformations from back at 1.5 and a little graphing of linear equations. And this one we've sort of seen, but we haven't quite seen it in this form, so I'll explain that when I get there. So on the test, I'm going to ask you to only shade the part that you want me to grade. Otherwise, I kind of get this big blob of shaded stuff that I can't tell what the answer is. And so I'll show you how I kind of keep track of things when I'm doing it. So for this first equation up here, it's going to be an x squared. It's got a minus in front, so it's parabola opening down and shifted up 3. So I'll start up here at 3, and then over 1 down 1, over 1 down 3, and matching points on the other side. So look about like that. The next one is maybe there. And it's got an equal, so I'm drawing a solid line. And if I test 0, 0, I get 0 is less than or equal to 0 plus 3. So 0 is less than 3, that's true. So this would be shaded on the inside. And I usually just do a couple arrows to remind myself which way it goes. The linear equation, so this is my y-intercept, so it's at 1. And then it goes over 1 down 2, because our slope is negative 2 over 1. So I just kind of trace that down, just to kind of help myself draw a halfway straight line. Oops, and that's supposed to be dashed. There's a lot on the test. If you do that, just write dash, and I see that a lot. So just do the same correction I just did. And then let's see if we try 0, 0 there. 0 is greater than negative 2 times 0 plus 1. So 0 is greater than 1, and 0 is not greater than 1, so that is false. So that means the side with 0, 0 doesn't work, and so this side does. So the overlapping shaded region, the green one shaded on the inside, the blue one shaded above, so it would be right in there. So for the test, if you would just shade like that, that would be really helpful. Number 10, this is x squared plus y squared is greater than or equal to 16. What this one is the equation of a circle. And it's basically the exact same thing as an ellipse. If I divided everything by 16, to make the side equal 1 and put it in the form of an ellipse, we can say A equals B, and so that's just what a circle looks like. We don't usually write them in this form. This is the radius squared. And so this is centered at the origin because there's neither an x nor y transformation. And then with a radius of 4, since that's r squared. And that's the same thing down here. So we'd have a circle of radius 4. And it is solid. And so if I put in 0 is greater than 16, that's false. So this is going to be shaded on the outside. And then this one, x plus y equals 4, that's a linear equation. So we could just do an easy little table. If x is 0, then y is 4. And if y is 0, x would be 4. So it would be there, and this one is dashed. And let's see, 0 is greater than 4. 0 is not greater than 4, so that's going to be this side. And so that means the place where they're overlapping is outside the circle and above the line. So everything kind of through there. Okay, so another circle, so it's just going to be radius 2 this time. And again, centered at the origin. And they are both equal, so you don't have to try to draw a dashed line. And this one, 0 greater than 4 is false, so the origin does not work. So that means we're shading outside. And then this one is going to be a parabola shifted down 5. So we'll just start the vertex down here at negative 5, over 1 up 1, over 1 up 3, over 1 up 1, over 1 up 3, something like that. And it is solid. Something like that. And this one, if I do 0 is greater than or equal to 0 minus 5, 0 is greater than or equal to negative 5. So the interior works. So the exterior of the circle works, and the interior of the parabola works. So that means basically I have to exclude the interior of the circle. So it's going to be kind of this area, and then all of that up there. Okay, and that brings us to partial fraction decomposition, everyone's favorite. So you do get this for the exam. So this is reminding you for non-repeated linear roots, each root gets its own A, B, C, etc. For repeated linears, this is saying for however many iterations we have, so they're showing 3 going to infinity here. Let's say it was a cube. I need a linear term, a squared term, and a cube term, and each one gets its own constant. Non-repeated irreducible quadratic, so if it reduces, which is to say it can be factored, you need to factor it down to its linear terms. But irreducible, so then that gets a linear term above ax plus b, and as many of those as we might need. And then the repeated irreducible work the same as this, that we just need as many iterations as there is the highest degree. Okay, like most of the problems, this one's a combination of a linear term and an irreducible quadratic. Usually there's some kind of combination going on. So this is going to be a x minus 1 plus, and then bx plus c, x squared plus x plus 3. And then we do our LCD both sides to clear the fractions. So this right here is the LCD. So on this side, I'm just going to write LCD. I'll write it out over here. So on this side, I just get the 3x squared, the minus 6x minus 7. Over here, whatever's here won't be with a, because that's what's canceling. So it'll be a times the trinomial plus b, and then times the linear one, or bx plus c, I guess. And so I only have one 0. I'm going to use it. It's x equals 1. So if x equals 1, this becomes 3 times 1, and then minus 6 times 1, minus 7. And this will be a, and then 1 plus 1 plus 3. And then this 1 minus 1 is 0, so it knocks out these 2. So then this is, let's see, 3 minus 13, so that's going to be negative 10 over here. And on this side, 1, 2, 3, 4, 5, 5a. So it looks like a equals negative 2. And once I have that, I can put it right there for that a. And I'm going to go ahead and FOIL this out while I'm doing this. So bx squared, and then minus bx plus cx minus c. And then distributing, fortunately lots of writing. And I think here I'll go ahead and factor out, actually I'm going to write them in the opposite order just because it will look better. So I'm going to do this, just because I like a positive leading term. And then here I'm going to bring everything over that I can. So that's going to be plus 2x squared plus 2x plus 6. So that gets me 5x squared minus 6 plus 2, so minus 4x minus 1. Those all cancel, that was the plan. And that's going to equal, oops, I dropped a squared right there, bx squared. I'm going to factor the x out of these, so that will be plus c minus b times x, and then minus c. So with that gives me a lot of information. So I'm going to match the coefficients. So right here I have 5 and x squared equals bx squared. So right there I know that b equals 5. Right here I have negative 4 equals C minus B, so not quite as good, but still pretty good. C minus B equals -4, but I don't really have to care about that one because right down here I have -1 equals -C. So -C equals -1, so C equals 1. So I can get that right there, and there's B. And so my answer would be, let's see, A was -2, x minus 1, and B is 5x, and this is +1 over the trinomial. Okay, then I got one more of these, and this time with a repeated linear factor. So this is going to set up A x minus 2, and then we need B over x plus 3, because that may or may not be needed. And then we're definitely going to need C over x plus 3 squared. And so you can kind of see that the common denominator is the same whether that term is there or not. So I have to allow for its the possibility of that term. I'll multiply both sides by the LCD. And so over here that's x minus 2, x plus 3 quantity squared. And then these cancel. And we're left with -2x squared plus 13x plus 32. And over here, the x minus 2's cancel, so I have a times x plus 3 squared plus b. So one of the plus 3's is going to cancel, so I'll have b and then x minus 2, x plus 3 plus c. The x plus 3's are going to cancel, so times x minus 2. So this time I have a couple of zeros, so I will use those first. So I'm going to let x equal 2. And so that's going to give me -2. 2 squared would make a 4 right there. Plus 13 times 2 is going to be 26 plus 32. And then a, this would be 2 plus 3 squared. And then those will both drop out because 2 minus 2 will make a 0 here and here. So that is -8 plus 26 plus 32, and yay for lecture notes, I guess that comes out to 50 equals, this is 5 squared, so that's 25a. So that gives us a equals 2. And then next I'll let x equal -3. And when I do that, so I'm going to get -3 or -2 here times 9 would be -18. -3 times 13 would be -39, and plus 32. This drops out because -3 plus 3, same thing here. And so the only term to survive is c down there. So c and then -3 minus 2. And so let's see, this comes out to, they have 18, 32, 32, so -25 equals, oops, don't need the parentheses, sorry, -5c, and so c equals 5. And then I need one more solve. And so when I just have 1 0 left, when I already know 2 of these other values, because I just need b, I know everything else, I'm just going to let x equal 0 because it's easy. And so that knocks out these two terms, and I'm left with just 32 on this side. A, it turns out, was 2, and then that's going to be times 3 squared, so times 9. B is going to be times -2 and +3. C is 5, and that's going to be times, oops, that should be a plus right there, sorry, times a -2. So kind of cleaning up the mess a little bit, I get 32, 18, minus 6b, and that's going to be -10. And so 18 minus 10, that's going to be 32, 8 minus 6b. Subtract the 32 over and get 24 equals negative 6b. And then finally b equals negative 4. So my solution will be 2, x minus 2, minus 4, x plus 3, and then c was 5. X plus 3 squared. Okay, so this is section 9.6. And in this section, we did matrices. What I would do on my test is I'd actually probably present it this way and then just say solve. And you can pick the method of your choice. So if you prefer the matrices, you're welcome to do that. I did that in the notes. So I think in the video I'm going to do the 9.2 version just to kind of remind you what that looked like. So I'm just going to call these equations 1, 2, and 3. And then I'm going to go to the negative equation 1. I'm going to add equation 2 to that. So that'd be negative x plus 3y minus z equals negative 4. And x minus 4y plus 4z equals negative 1. And adding those x drops out, I get negative y plus 3z equals negative 5. And so back in 9.2, we called this equation 4. And it would have been our new row 2 if we were doing matrices. And then I'm going to do 2 times row 1, I think, and add it to row 2. So 2 times row 1, add it to, sorry, row 3, excuse me. So 2x minus 6y plus 2z equals 8. Negative 2x plus y minus 5z equals 3. So that drops out. I get negative 5y minus 3z equals 11. And then these turned out pretty good because I can just add these two equations together. And this is equation 5. So if I go 4 plus 5, negative y plus 3z equals negative 5. And then 5y, oops, negative plus 3z, so the z's are going to cancel, equals 11. And then I get negative 6y equals 6. So it looks like y equals negative 1. So that would be my first solution. And then, so let me recap what I did there. I took 2 equations. I decided I was going to eliminate x. First off, I don't think I actually said that out loud, sorry. It looked like the easiest of x, y, and z, so that's why I picked that. I eliminate x out of my first pair. I eliminate x out of my second pair. That gave me 2 equations with 2 unknowns. And then z looked like the easiest thing to eliminate, so I did that, and they got me my first answer. Once I do this, I can come back to equation 4 or 5. 4 looks a little bit easier, so I'll do that one. So going back to equation 4, I'm going to go negative 1 is 1, plus 3z equals negative 5. Subtract the 1 over. 3z equals negative 6, and then divide. And z makes negative 2. I can go back to equation 1, 2, or 3. I guess 1 looks the easiest, so I do that one. So x minus 3 times negative 1, plugging in y, and then minus 2 for the z equals 4. So that would be x plus 3 minus 2 equals 4. 3 minus 2 is 1. Bringing that over, I get x equals 3. So the solution set is 3, negative 1, negative 2. And again, how you get there is, for me at least, your instructor may have a different idea on that. I'm fine with either one of these methods. So then there's the method that, now and again, someone will pick it for that last one, but not very often. So Cramer's rule is that one where we had to use determinants, and we end up doing 4 3x3 determinants and then take in the ratios. So if I put one of these on the test, it will say, I promise, it will really say this, solve for z only. Someone will not read the directions and they'll do x and y and do twice as much work and waste lots of time. So try not to do that. This is going to be for z only. So we want to remember set up d and dz. So I'll do d first. And you can do this either of the methods for solving the determinant. I think the one with the diagonals is easier, so I'm going to do that. And let me set that up over here to kind of remind you what it looks like. So that would be D right there. And then to do the diagonal one, we just repeat the first two rows. So you set up whatever you're setting up and then repeat the first two. And then remember, we just multiply down the first, second, and third diagonal and add those, and then up, 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 and then those are all subtracted. So let's see, this is going to be 1 times negative 4 times negative 5 is negative 20, or sorry, positive 20. And then double negative, so this will be positive 12 times 2 is 24. And the third diagonal is 1 times 1 times 1, so plus 1. And then I can do this as, minus and then do all the signs at once, which I think sounds easier. So this will be 8. And then I'm just thinking of it as addition inside, and I'll distribute the negative after I collect. 1, 4, and 1 would make 4 because we're multiplying. And then negative 5, negative 3 would be positive 15. So that's 20, 44, 45. Do over here. Minus 12, and that'd be 27. And so I think that is 18, 3, 5, yep. So D, and this was D equals, so D equals 18. And I'll do the same thing with DZ, so this first two columns are the same, and then the equals hops in for the Z. So 1, 1, negative 2, negative 3. And so there's the only change, so this hops in for the Z column, the equal side. And we'll just do that same thing. So this is DZ. So multiplying down, I get negative 12. And then 3 negatives makes a negative 6. No negatives makes positive 4. And I'll just write minus in parentheses again. And then going up, I get 8 times 4 would be 32. Positive, 2 negatives. And then minus 1 and minus 9. So that'd be negative 18 plus 4 would be negative 14. And then 32 minus 10 would be 22. And that equals DZ, and it is negative 36. So then to find Z, I just do DZ divided by D. And so that's negative 36 over 18, or Z equals negative 2. Okay, so that gets us to chapter 11. 11.1 was just a little intro section, so nothing there for the exam. 11.2 was the arithmetic sequences, and 11.3 were the geometrics. That's where I pull questions. This first one is given a Okay, so that gets us to chapter 11. There wasn't really any, 11.1 was more of an intro section, so the focus will be on 11.2 and 11.3. 11.2 is arithmetic sequences, and remember we had a couple of sets of formulas for that. We have this nth term formula here, and then we'll see the sum formula in just a second. So this first problem is given a sub 1 equals negative 5, d is 3, find the nth term and the 37th term. So to find the nth term, I'm just going to plug these in and clean it up. So a sub n equals the first term. Actually, let me write that a little bit bigger so you guys can see. So that's what I'm plugging into. So the first term, minus 5, plus n minus 1, and d is 3. So a sub n, negative 5 plus 3n minus 3, and a sub n equals 3n minus 8. And if I want to find the 37th term, then I have this nth term formula, so I just plug in 37. So for the 37th term, we go 3 times 37, and then minus 8. and that is apparently 103. Okay, for this one, given the arithmetic sequence, 7, 13, 19, 25, find the 24th term. So I don't have to mess around with the nth term this time. We know a sub 1 is 7, and 13 minus 7 is 6, 19 minus 13 is 6, so d, plus they said it's arithmetic, is going to be 6. So to find the 24th term, I'm doing 24 for n, and then the first term is 7, n is 24 minus 1, and d is 6. So then the 24th term is going to be 7 plus 23 times 6, and that apparently comes out to 145. So this one goes find the sum of the first 47 terms of the sequence this, and it's arithmetic because the common difference is 4, and a sub 1 is 11, and we know n is 47. And so we look at our two versions of the sum formula. We don't know the 47th term. We could, but we do know all this stuff. We know n, we know a sub 1, we know d. So we'll just use this version. So the sum through the first 47 terms is going to be n over 2, so 47 over 2, 2 times the first term, so that's 11, plus n, which is 47, minus 1, times d, which is 4. So I'm just going to leave that fraction for now. And this is 22 plus 46 times 4. And then if I clean this up, go 46 times 4 plus 22, that's going to get me 47 halves, and then that's 206. And then I would just divide the 2 into that and make 103 and multiply it by the 47. And so then I get the sum of the first 47 terms is 48, 41. Okay, so this one is, if the 7th term is 21 and the 42nd term is 14, find the sum through the first 40 terms. So to find the common difference, I'm going to use that idea of slope again, because if these are the terms, there's so much space between them, and this is the 14 and the 7 are the number of integers. So if I divide the kind of the distance between the numbers by the number of integers, that's going to give me the increments that it's increasing by. So this is going to be distance equals 42 minus 21, so outputs over the change in the input, so 14 and 7. So that would be 21 over 7, or 3. Once I do that, then I'm going to use that nth term formula. So we have I'm going to use this one, so n is 7, and a sub n is 21. So the 7th term is 21. I'm using this to find the first term, because we don't have that here. I guess I could count backwards by 3s from 7 and get there, but it just sort of seems like a cheater way. That really is perfectly fine. So this is 7 minus 1 right here, n minus 1, and then times the common difference of 3. So 21 equals a sub 1 plus 6 times 3. 21 equals a sub 1 plus 18. And then bring the 18 over. And this is 3. And let's see, so we got the first term, we got the difference, and now I'm supposed to find the sum through 40. So that's going to look like 40 over 2, and that's this formula. And then it goes 2 times the first term, so 2 times 3 plus n is 40, and then minus 1, and then 3 is the common difference. So that's going to be 27 6 plus 39 times 3. Cleaning that up, I get 123, it looks like. And then multiplying sum through 40 is 2460. Okay, so this one goes, the sum through the 25th term is 1300. The first term is -8. Find D and find the 30th term. So I have the first term, and once I find D, I'll have the nth term formula, and I can find this. So what I need to do right now is figure out how to find D. And they gave me a sum, so looking back at those formulas that were our sum formulas, the slightly more complicated one has a D in it, and I think I know everything else. I know the sum, I know N, and I know the first term, so that's going to let me solve for D. So this is going to look like 1300 equals, let's see, so N is 25, the sum is 1300, we got A sub 1. So it's N over 2, so that's 25 over 2, and then 2 times the first term, which is at -8, and then plus N 25 minus 1 times D. So 1300, again, I'm just going to leave that fraction and see if I can clear it at the end. -16 plus 24D. I think I'll get rid of the fraction right here. So I'm just going to multiply both sides by 2 over 25. So those cancel. I can just do 2 over 25 right there. Kind of think of that as over 1. And let's see, that gets me 104 right here, equals -16 plus 24D. Adding 16 over, I got 120, makes 24, oops, D. And then I can divide the 24 out on both sides. And then that gives me D equals 5. And so with that, and then the nth term formula, I can find the 30th term. So to find the 30th term, that's where we do the first term plus n minus 1, so 30 minus 1 times the difference. That'll be a plus 29 times 5, and then the 30th term is 137. Okay, so that brings us to the last section, which is 11.3, geometric sequences. And so this is when we have the common ratio instead of common difference. And this first one, we're given the first term and the ratio, and has to find the nth term and the 9th term. So very similar to the first problem in 11.2. So the nth term is just going to be kind of plug it in here. So A sub 1 is 5, and then the ratio is 2 raised to the n minus 1. And then to find the nth term, I can just plug in 9 for n. So that'll be 9 minus 1 up there. So that's going to be 2 to the 8th. And then if we chunk all that into a calculator, it's going to come out A sub 9 is going to come out 1280. Okay, question 22 we got. Given this geometric sequence, find the 8th term. So again, very similar. We can get A sub 1 right there. So that's -2. And to find the ratio, remember we just do the second term over the first term. We kind of think of that as a 1 if it helps. So it'll be 2/3 and then times -1/2. 2's cancel. And I get -1/3 for my R. And then we just plug that into the nth term formula. So A sub n, which is 8 in this case, equals the first term, which is -2, and then the ratio, which is -1/3 to the n minus 1, and that's 8 minus 1. So 8 sub 8 equals negative 2, and then 1/3 to the 7th. And then I would just put that 3 to the 7 in a calculator. And that's going to give me, and there's also, so an easy way to look at the signs, you have 7 negative signs here, 1 here, so our answer is going to be positive. This is like 2 over 1, so 2 times 1 makes 2, and then 3 to the 7th downstairs. So 2187. Please don't give me a decimal. We're looking for an exact answer there. Okay, then for finding the sum, we had 2 formulas for that. We had for a finite number and for an infinite number. And so for the finite one, if that, we just plug into here. So this is the sum through the 18th term. And this one is negative 8. R to the n, so negative 1 to the n, and n is 18, minus 1. And this is another one of those ones that is going to be 0. And then r again was negative 1 minus 1. So this is negative 1 to the 18th is 1. So this becomes 8, 1 minus 1 over negative 2, but that's 0. So it's 0. And this last one, number 24, is find the sum of the infinite geometric sequence. So that means we're using the one without the n, and then they're giving us a sequence. So pretty much we just grab the first term in the ratio, and our ratio is going to be 5 over 10, or 1/2. Plug them in here and get the infinite sum. So that will be, the first term is 10, and then 1 minus 1/2. So 10 over 1/2, that flips over and becomes 10 times 2, or 20. And that wraps up the exam 3 review.